Decision tree analysis is a method used to evaluate potential options when making a decision under uncertainty. In this method, each alternative, their potential outcomes, and the probability of each outcome are visually represented in a tree-like structure. By calculating the expected monetary value of each path, project managers compare various courses of action and determine the optimal course to follow. To illustrate, say that a project manager needs to decide between two vendors to procure materials for the project. Vendor A provided a bid of $90,000 and has a 30% probability of delivering late, which will incur an additional cost of $15,000. On the other hand, Vendor B provided a bid of $80,000 and has a 50% probability of delivering late, which will incur an additional cost of $30,000. To evaluate the potential outcomes of working with each vendor, we will create a decision tree that visually represents the alternatives, potential outcomes, and the probability of each outcome. In this scenario, there are two possible outcomes when working with Vendor A and two possible outcomes when working with Vendor B, resulting in a total of 4 possible outcomes. The total procurement cost in each outcome is calculated as follows. Outcome number 1. If Vendor A is chosen and delivers on time, the total amount spent on procurement will be $90,000, which is calculated as follows. $90,000 plus $0 equals $90,000. Outcome number 2. If Vendor A is chosen and delivers behind schedule, the total procurement cost will increase to $105,000, which is calculated as follows. $90,000 plus $15,000 equals $105,000. Outcome number 3. If Vendor B is chosen and delivers on time, the total amount spent on procurement will be $80,000, which is calculated as follows. $80,000 plus $0 equals $80,000. Outcome number 4. If Vendor B is chosen and delivers belatedly, the total procurement cost will increase to $110,000, which is calculated as follows. $80,000 plus $30,000 equals $110,000. To decide which vendor to choose, we also need to take into account the probability of each outcome along with its total cost. In other words, we need to calculate the total expected monetary value for each vendor. To do so, we first calculate the expected monetary value of each outcome by multiplying the probability of each outcome with the total cost for that outcome. Then we calculate the total EMV for each vendor by adding the expected monetary values of all the outcomes associated with each vendor. Let's calculate the expected monetary value of all the outcomes in our example, and then calculate the total EMV for each vendor. The EMV of outcome number 1 is calculated as 0.7 multiplied by $90,000, which equals $63,000. The EMV of outcome number 2 is calculated as 0.3 multiplied by $105,000, which equals $31,500. The total expected monetary value for Vendor A in this case can be calculated by adding the EMV of outcome number 1 to the EMV of outcome number 2. That is, $63,000 plus $31,500 equals $94,500. Now let's proceed with calculating the EMV for outcomes number 3 and number 4. The EMV of outcome number 3 is calculated as 0.5 multiplied by $80,000, which equals $40,000. The EMV of outcome number 4 is calculated as 0.5 multiplied by $110,000, which equals $55,000. The total expected monetary value for Vendor B in this case can be calculated by adding the EMV of outcome number 3 to the EMV of outcome number 4. That is, $40,000 plus $55,000 equals $95,000. Based on the decision tree analysis, the project manager should choose Vendor A as it is expected to cost less compared to vendor B. However, note that the decision criterion for selecting the best choice may differ based on context. Our example decision tree was created for a cost minimization problem, choosing the most cost-effective supplier. As a result, the decision with the lowest EMV is the best choice. If a decision tree is created for an investment decision, such as choosing the most profitable investment, the decision with the highest expected monetary value would be the best choice. Lastly, let's take a look at the ultimate tips for exam success. Thoroughly understand the logic of decision tree analysis. You may be asked to calculate the expected monetary value of the given paths in a decision tree and determine the optimal course to follow. In a decision tree, first calculate the cost of each outcome associated with each decision by adding all the costs in that path. Next, determine the expected monetary value of each outcome by multiplying the total cost of each outcome with its probability. Finally, find the total expected monetary value of each decision by adding the expected monetary values of all the outcomes associated with each decision. If the decision tree is created for a cost minimization problem, such as choosing the most cost-effective supplier, the decision with the lowest expected monetary value would be the best choice. On the other hand, if the decision tree is created for an investment decision, such as choosing the most profitable investment, the decision with the highest expected monetary value would be the best choice.